Hello everyone and welcome to our daily coverage of the QUIC League 2020. And boy do we have a treat for you today. As the season is halfway through and the playoffs start next week, we thought it would be interesting to look back at the different strategies that all the teams have been using to win their games. I'm your host this evening, Robin Marks, and I'm joined today by Joris Herbots. How are you, Joris?
I'm doing just fine, Robin. Thanks for asking.
That's nice to hear. So, for those of you new to the stream, remember that QUIC, you can see it as kind of an updated rule set to the TCP sport. And while, of course, TCP Cup is also still running this year, it's the first time that we have an actual major QUIC tournament with new features like stream multiplexing, zero RTT, and complex congestion control. Now, some of you might be thinking, but wait, QUIC has been around for a few years, right? And that's true, but for a long time, there was just one professional team playing against itself, which got boring quite quick. So it's nice to see that over time, we've had some new professional teams rise to the challenge, and so we can have the first real tournament this year. And so we've looked at all these teams, and the way we did that is something that Joris can tell you more about.
In order to deduce the strategies used by these many different QUIC teams, we watched a lot of footage. And to gain additional insights, we uploaded all this footage to the QVIS match viewer. We used two types of footage, the first one being the official QUIC League footage provided by the QUIC Interrupt Runner project. The second type being test footage by some bright AOQUIC team players who performed some non-standard strategies just to see how other teams would react.
We then presented our findings to the coaches of the individual teams to see if we had interpreted the strategies correctly. This way we were able to analyze 15 of the 18 participating teams, with at least 9 of them for each of the features that we looked at. The first one of those is flow control, which Joris will explain to you now.
An example of where QUIC is more advanced than TCP is in the area of flow control. With TCP, there is only one single connection level flow control limit called the receive window. Yet, in QUIC, due to the availability of multiple streams, there are 3. And as we all know, it's very important to keep these limits high enough and updated frequently enough to avoid stalling. In practice, we noticed 3 different approaches for our QUIC teams. The first one is a static approach, which keeps the overall memory requirements constant. The second approach is a dynamic approach, which doesn't care about that and simply doubles the limit to avoid stalling. Yet, it is very important that all these limits are updated at the same time, else stalling could still occur, as can be seen in the right image. A third approach, auto-tuning, balances memory with achieving the optimal sending rate. This is done by many TCP teams, yet not by many QUIC teams. Only one seems to implement this. Others have mentioned that this is because they haven't spent time fine-tuning their stacks and simply play it safe to avoid stalling in practice. There is still lots of area to improve here. An example of stalling is provided in this game footage. Here we see the purple congestion window is set quite high, and the yellow bytes and flights never seem to reach it because of the pink flow control limits, which update linearly and slowly over time. Next up is multiplexing. I give it to you, Robin.
Thank you, Joris. Multiplexing is indeed a very important topic in QUIC, because as you said, we now do have individual independent streams, but we still need to send them on just a single underlying QUIC connection, which means that we need to distribute our bandwidth across the streams somehow. Now, there are 2 main ways of doing this. First, we can send them sequentially back to back, all the stream data in one go, or we can subdivide them into smaller chunks and send them in a more round-robin fashion. If we look at how the QUIC teams have been doing this in practice, we see that some indeed follow round robin quite rigorously, others choose sequentially, and there are some that even combine the 2 in some weird forms in the middle there. Now, interestingly, this is only at the QUIC level. As you might remember, there is actually a second tournament starting next week, which is the HTTP3 Invitational, which updates the QUIC rule set with even more advanced strategic options. One of those is prioritization, which allows you to indicate on a per stream basis how important the stream is and if it should be sent sequentially or round-robin fashion. So you can do even more complex things, as we see on the bottom there. Sadly, it's an invitational for a reason, because there are only a few of the implementations actually implementing this prioritization stuff. All the other ones are still stuck at the more simple approaches, with most of them opting for round-robin and only a few choosing sequential, which we found a bit, weird, because if you look at web performance tournaments in the past, sequential has turned out to perform much better than round-robin. So definitely interesting to see how this evolves. Another important aspect for QUIC versus TCP is that in TCP, if you retransmit things, you always need to retransmit them in the order you originally sent it. This is no longer the case in QUIC, because with the independent streams, we can now retransmit in whatever order we want, or even mix in new data from other streams before we retransmit all the lost data. This allows for even more complex things. For example, we can simply not treat the lost packets any differently from normal data. We could do just exactly what TCP does, which is number 2. Number 3 is alike, but changes the underlying scheduler depending on if it's a retransmission or not, which you can see in the bottom image, which normally does round robin, but when there's time to retransmit, it actually switches to a sequential scheduler for some reason. And the fourth thing is that we could actually start to incorporate the prioritization rules from HTTP3 into this as well. For example, you could say if I have a high priority stream, why not send that data before retransmissions from a low priority stream and get better performance that way. However, it's clear to see that this is all very, very new. Very few people have started experimenting with this just yet, and most of them simply choose the well-known TCP approach. It's only a matter of time, I think, though, before people start seeing potential here and start experimenting with this more. Now on to the thing that everybody was waiting about is, of course, congestion control. Take it away, Joris.
Thanks, Robin. So in a game mostly dominated by speed, congestion control is one of the main things that teams can tweak for extra performance. As we've seen with TCP over the years, there has been a huge evolution, with things like BBR even abandoning the status quo completely. But when we look at the QUIC rule set, we only see mention of Neurino, which is strange, because isn't Neurino an outdated approach? Well, yes it is. But congestion control is more than only congestion controller. A major part of the congestion control is loss and congestion detection logic. And even though the QUIC rule set might be running behind on pure congestion control logic, it does combine all the best of TCP loss detection, which allows big players to implement their own congestion controller or even adapt TCP congestion control to QUIC. And when we look at all our teams, we can see that most implement Neurino, and some going even beyond that with extra options or even implementing multiple congestion controllers. We even see some nasty mind games. For example, this team claimed to be doing QUIC, but in reality they were doing Neurino, which is very sneaky if you ask me. And as always, the devil is in the details. It's more than only choosing the best of the right algorithm, it's also about choosing the right settings. For example, a larger initial congestion window can mean a speed up at start at risk of early packet loss. Another example is spacing, which is the spreading of packets over one round trip time instead of in bursts, which is recommended by the QUIC rule set, but yet is only done by 8 out of 50 players. And finally, acknowledgements can also have a big impact on performance, with 2 QUIC teams following the QUIC rule set of acknowledging every second packets, and others acknowledging all over the place, some doing that intentionally. And this is mostly due to how they read from the socket, which is in batches. There is much room for improvement here, if you ask me. Back to you, Robin.
Yes, and this is for one of QUIC's most interesting features, which is zero RTT connection establishment. Because as we all know, RTTs are just not fun at all. And still, TCP typically takes 3 to even 4 round trips to get back application layer data from the server. Now, QUIC and H3 try to optimize that and bring that down to just 2. And if you're using zero RTT, everything can typically be done in the first round trip. Now, zero RTT is quite complex because of that. And I kind of compare it to the offside rules for soccer, because if you already know them, you already know, and if you don't, you probably don't care, right? So let's skip all the nasty security-related details. All you really need to know is you can only do zero RTT from the second connection onward, and the server cannot send back more than 3 times the amount of data it has received from the client first, at least during the first round trip, which is called the amplification limit. Let's see what it looks like in practice though. So this is the first connection from the client to the server. We need a separate handshake and only can then send our 1RTT request for HTTP data. The server sends along what is called a session ticket, which the client can then use for its second connection to indeed enable our zero RTT handshake. We can also see the server can also only send back those 3 times data because of the amplification limit. Now in practice, this is only about 4 to 5 kilobytes, which is okay, but not great, right? So how can we make this better? 2 main ways. First of all, the client could send additional data, for example in the form of padding, to allow the server to reply with more. Another option is that the server can send along what is called an address validation token along with its first connection, and then the client can use that in the second connection to prove to the server that it is going to do no shenanigans, and they can trust it, and so the server can reply with up to its initial congestion window with data, which is typically fantastic. However, if we look at what the QUIC teams have done with this, it's not that great. Not everyone supports this already, even though it's like a main QUIC strategy to use for performance. And of those that do, none of them actually add the extra padding, and slightly half only add the address validation token, even though it's highly recommended by the QUIC spec. We even found some teams that were very willing to break the rules, that weren't being very safe out there in the sport with regards to the amplification limit. One of them simply completely ignored it, and together with a very high initial congestion window had a very large amplification factor. The second one did apply the limit, but only for normal data, not for retransmissions, which also led to amplification. And the last one had trouble getting their congestion control integrated with zero-RTT due to the complex QUIC handshake. So zero-RTT, one of the most touted performance-related features of the new QUIC sport, difficult to get right, interesting to follow up in the next matches. With that, we've gotten to the last feature we'll discuss, which is packetization with Joris.
Thanks, Robin. For packetization, we can be quite brief. Due to time constraints, we are not going to explain more in this talk, but if you want to know more, I'd recommend you read our paper, which brings us to the conclusion.
Okay, in summary, let's look at what we've learned today. We've seen that the QUIC rule set is indeed quite a bit more complex than what we're used to from TCP, and that all the new strategies haven't always been adapted as well as they could be by all the different teams. But that's of course what makes it so interesting to watch these early tournaments get up and running. This also means that if you yourself would be interested in looking more deeply into QUIC, it really pays to look at a couple of the different teams at the same time. We really can't do what we did before with Google and just watch one of the teams playing itself, because it's no longer realistic with all these different strategies and approaches going on. If you would like to do that, we suggest you take a look at how we did it, because we launched a ton of different game footage in the QUIC Match Viewer, which really helped us get to the bottom of these strategies much more quickly. With that, we hope you will join us next week for the playoffs. Until then, Joris and I would like to say good afternoon, good evening, and good night.